Hello friends, I am Professor Anil Brahmin from Sri Sankaracharya Technical Campus, and in this video I will elaborate the electric field due to infinite line charge density which is laying on the z-axis, as we have shown here in the diagram. On the z-axis we have shown the line charge which is existing from minus infinity to plus infinity and having the line charge density as rho L coulomb per meter. And due to this, we want to evaluate the electric field intensity at the distance rho from this line charge. And for that, we have deduced a very simple technique by using the well-known Gauss law. The Gauss law is, say, d dot ds surface integration closed surface integration equal to q. Here, for application of Gauss law, we should keep in mind that we should select the surface such that the direction of d and surface direction should match. Then this dot product will be replaced by the multiplication sign. Now coming to our diagram, see here, as we are knowing, due to this line charge, the electric field intensity as well as the d electrical flux density will be radially out, will be in the arrow direction, and thus we have chosen a cylindrical surface at the radial distance rho. If we are choosing a cylindrical surface, we have to define the ds vector. Now this ds vector, as you are seeing, for this surface, this distance is dz and this distance will be rho d phi, because angle is d phi, distance will be rho d phi. Thus the surface vector will be this distances rho d phi into dz, and direction will be radial arrow, because the surface vector will be vector at the normal to the surface and going out from the surface. So this is the surface vector direction, which is arrow. Now after this we can apply this Gauss law, and we will have, because the d direction is in the arrow direction, and as we have seen, the surface vector is in the arrow direction. Thus we can have the surface integration, and the limits of integration will be, z will be from 0 to h and phi will be from 0 to 2 pi. We may have z equal to minus infinity to plus infinity also, no problem in that. And this expression must be equal to the charge enclosed. If you see the charge enclosed, see here, rho L is the line charge density, coulomb in coulomb per meter, and small distance is dz. Thus the total charge will be, again, integrated should be from 0 to h or minus infinity to plus infinity. As you can see in the diagram also, this dq will be rho L into dz for this small distance. This is to be integrated for calculating the total charge. Thus here we are having the expression like this, and now as we are seeing, this arrow dot arrow will be equal to 1. This is the surface vector and this is the d vector. Both are in arrow direction. Thus this will be replaced by, dot product will be replaced by a multiplication sign. One more thing which we have to see here is, here the integration of dz is there, here also integration of dz is there, limits will be same, 0 to h or minus infinity to plus infinity. Similarly here also 0 to h or minus infinity to plus infinity. Thus this integration of dz will be common in both the sides, will be cancelled, and will have the integration of d rho and d phi. The limits will be 0 to 2 pi, which must be equal to, because this integration dz integration will be cancelled, will have, this must be equal to rho L. Thus if it is integrated, the d phi will be integrated, will get, because limit is 0 to 2 pi, will get 2 pi here, and it will be d rho into 2 pi. Thus the electrical flux density will be rho L divided by 2 pi rho, and this will be in the arrow direction. This direction, because we have already assumed it is there, this thing is there in the Gauss law. We must know the direction of E or D, then only we can choose a particular surface which is in the same direction and we can apply it. Thus this direction must be known to us. Thus now E due to line charge will be d by epsilon naught, because this is the relation between d and E. Thus the expression of E will be rho L by 2 pi epsilon naught rho arrow. Thus in this way we can derive the expression of electric field due to infinite line charge by using Gauss law in a very easy manner. Thank you.